Hello, everyone. Thank you for joining. I have a few questions to start with, and I think I'm going to know how many people are going to raise their hands, but very curious. How many of you have used ChatGPT? There you go. That's what I guessed. Second question. How many of you trust the answer ChatGPT is giving you? If it's correct, how many?
Depends on the question.
There's someone there. Yeah, because I can tell you that if you ask ChatGPT who I am, it's one bunch of lies. Really. There are few facts here. My name, where I live, and where I work. Those three things are correct. This is not fully true. I asked my manager if I got a promotion. He told me to go away. Also, I know about Teams, I use it every day, but don't ask me like how he works and all that type of stuff. I'm in identity. Also, I called ASML and asked them if I could get some money from them because ChatGPT told me that I worked there. But they were like, we don't know who you are, you never worked here. So very interesting to see how some data gets out there, and I really love to see that nobody except you. One person raised his hand and said that you trust the data that's coming out of this. And this is where this talk is mainly going about. In the end, it's going to be about trust. Can you trust the information someone is giving you? Can you trust me that I tell you I'm Stefan, but am I really Stefan? Maybe I'm his twin brother. I don't have a twin brother. Maybe that's also a lie. So welcome to an introduction to decentralized identity. So a little bit background about me. So I'm a senior product manager, that is true, with Microsoft in the Microsoft Entra team. If you don't know Microsoft Entra, it's not your fault, it's ours. We did a very bad job in communicating it, but it's basically all Microsoft Identity and Access Management products brought together under one new brand. So you can see it as the Office for Identity. Next to that, I have another big passion. Actually, someone came up to me and talked about it. It's radio, so I'm owner of a radio station. It's called Hot Dance Radio, and it's now not only online, but also on digital radio in a big part of the Netherlands, in everything above Amsterdam. So if you like some commercial dance music, go ahead and try it out. I did a course, so within Microsoft, once a month we have a learning day. And on that learning day, you need to pick something to learn about. So I thought maybe it would be good to learn about presentation skills. And one of the things of that course that got me is you need to ask the audience questions. And I thought that is fun, because now I can just have the audience run the meeting, and I can just sit here and watch the audience run the meeting. So to start with, who can explain the difference between centralized and decentralized identity? Anyone want to give it a try? I love it when it's quiet with this question. So a little teaser, then I need to do it, I think. So let's start with that. Because this is one of the things I hear the most from people when we're talking about decentralized identity. How does it compare to centralized identity? What is the difference? What are the components? How does it work? Why is it cool? Why should I use it in my apps? And why should I care about this? So these are questions that hopefully will be answered at the end of this session. So let's start with centralized identity, where we have two participants, and you can tell my really beautiful PowerPoint skills. I always forget to put in different colors. My favorite color is blue, so everything's going to be blue. And I used to say, when there's an animation in a slide, I stole the slide. Which is not true anymore, because there's an animation in this one, and I really built this slide myself. So we got two participants, participant A, participant B, and we got one central identity provider. Participant A and participant B, they want to exchange some data, they want to get access to each other's data, but they need to identify themselves. So they decide to both trust that central identity provider, and that's how it goes. Now, when others want to join in, we have other participants that can join in with that identity provider and have that trust relationship. That means that all these participants, when the identity provider gives them some information and tells them something, like that I'm head of engineering, they trust that it's true because it's coming from that trusted central partner that is there. If you're going to put it into standards or things that are there, we're talking about OpenID Connect, SAML, WSFET, on a very high level, of course. There's all kinds of differences between those, but one fun fact, I think, being in identity for almost 20 years, is that if you look at Kerberos, which is pretty old, and then look at OpenID Connect on a high level, you see a lot of similarities. And that's why I think also like things like decentralized identity is very interesting, as it is a different approach. A scenario here. So participant A and participant B's resource, and we have the identity provider. So participant A will navigate to the resource of participant B, will be redirected to the identity provider because there's where the trust is. So I need to identify myself with that identity provider. That gives a token. So basically a document saying, okay, it's you, and here's some information about you that you probably need to get access to this resource. And then participant A navigates to participant B with the token, and because participant B trusts the identity provider, it will get access to the resource. So again, all based on trust. Pretty easy, right? We have something in the middle that we all trust. How does it work in a situation where participant A and participant B didn't establish any trust? So there's nothing in between. There's no way of telling that participant A is A and B is B. So this is where we introduce something that is called the distributed infrastructure. And I see your heads going, you're probably already filling in what that's gonna be, but there's a reason I call it a distributed infrastructure. Now there is a trust. Both participant A and B will trust that distributed infrastructure. And how that distributed infrastructure looks is not important at this point, but I'm going to talk about that later. Now, participant B has a resource, same in the previous case, where participant A puts their identifier on that distributed infrastructure. So participant A will tell to that infrastructure, this is me, and this is my key I use to sign stuff. Participant A will navigate to participant B resource, and participant B will look up participant A on that distributed infrastructure. Based on the information that is on that infrastructure that is trusted, they can verify the request, and participant A gets access. That's basically high over how it works. And now I can all tell, like, this feels like magic. There's something magical that we trust, and it's distributed. So probably it should be blockchain, right? And what I love about blockchain, and that's the same kind of thing with AI right now. If you have a startup that has nothing to do with AI, but you need some money from investors, just put AI in your name. They will give you all the money they have. The same thing happened with blockchain. Years ago, there was a company in California who didn't do anything with blockchain, but they needed some money, and nobody wanted to give them money. So they changed the name. They added blockchain to their name, and suddenly they got a lot of money and could build their non-blockchain related stuff. Now, there are not only startups that are doing that. There's also a hotel. It's called the Blockchain Hotel. You can visit it. It's in Germany. It's in Essen. Although the one thing with blockchain is that it sounds pretty cool, and is a big hype, and there's a lot of use cases for it, but maybe a blockchain hotel is not the best way of using blockchain. It's closed. The one thing I want to say here is that this decentralized identity is not equal to blockchain. It could be blockchain, but it could be another different decentralized method that is there. Now, I put in all these slides because every time I did this presentation, someone somehow heard blockchain all over the place, maybe because I said it already 10 times. But I just want to point out very clearly that it doesn't mean that you need to do something with blockchain. And we will come to the blockchain topic later in the presentation, and also about the pros and cons of using it or not. But first I want to dive into what is decentralized identity, because it's not one thing. Actually, decentralized identity isn't even a thing. It's just a nice two words that we put together. But you can also think about SSI, self-sovereign identity, which basically means the same but different word. But it's not one thing. It's built out of multiple things. So to understand how it works and then understand how it can be applied to use cases, let's dive into those different things, those different layers. Cool thing is, those are all open standards. So decentralized identifiers is an open standard. What does it say in the open standard? It will tell you what is the scheme. In this case, it will always be DID, Decentralized Identifier. And then it will talk to you about the DID method, which sounds very fancy, and it is fancy, but it's a very important thing as well. Then we have the DID method-specific identifier, which depends on which method you use. Now, I can hear you think, what is a DID method? A DID method basically tells you how to read and write this DID document, which is part of the standard. Which means that if you go back to the participant A and participant B scenario, where participant A comes in with an identifier, the second step will say, what is the method? That method, participant B can use that to know where to find that identifier and where to find that trust. So the DID method basically defines which type of distributed infrastructure you are using. Then the identifier, I think that's pretty easy. It will just tell you where to look for in that infrastructure. Now, if we look at the decentralized identifier methods, there are currently over 80 different methods. And this is where it always goes wrong, right? We're going to invent a standard, we're all going to use a standard, and then we're going to make 80, 100 different versions of it. But still, because the overlayer is the decentralized identifier, it doesn't really matter which method you use as long as both parties will know where to find it and how to use it. So what you already see happening is that there are universal resolvers. So a place that supports 25 of those methods. So it doesn't really matter which method I use, I can look for it. And there are a lot of different infrastructures being used for those methods. So for example, you see Bitcoin over there, you see Ethereum, famous names, but you also see IPFS, which is a replication protocol that's being used. But there are also things like web servers. Web servers are also distributed. There are multiple web servers. Everyone has his own web server, can use that together with DNS, which is also one of the methods being used for decentralized identifiers. So it's very important if you look into this decentralized identity world to think about what is the method that I want to use, that I can use, is it supported, and all the other participants that I want to work with, do they also want to use this specific method? For example, think in Europe, from a European Union perspective, where they have the EPSI blockchain infrastructure. That could be one of the methods that they say, okay, we as an EU, we support that to do the decentralized identifiers there. Now, what is part of the decentralized identifier? It's a DID, basically a description of who you are. It's a set of public keys that used for verification and a set of authentication methods used for authentication. It's a set of service endpoints for interactions. Service endpoint, think about, for example, a revocation endpoint. Because you're going to learn in a bit that as soon as you give out one of those credentials to someone, they own it. It's in their wallet. They're the only one having that specific credential. So if that person, that credential will identify that that person is an employee of your company and they're leaving, you want to have a way to revoke that specific credential. And that could be as part of the service endpoint. There's a timestamp and of course there's a signature. Now, a little example of how such a document looks, it's just JSON. It's a JSON document. The whole standards define just how the JSON document looks and what's in there. So it's basically saying, who am I? What is my identifier? What are the keys that I'm using? So this is the information you can use to verify that it's me. This JSON document is put on that distributed infrastructure for others to use and to check. So this is the core setup where I build that trust layer. I have the distributed infrastructure. I put something on the distributed infrastructure for others to verify that it's really me. But that doesn't help with authentication or sharing information. The only thing that this says is that you are that identifier. This is how I sign stuff, and that's it. It's not saying how to exchange stuff and how to do that. That's another standard that's basically on top of this one. And if you're already lost at this point, we're going to put it all together later on, so you see the relationship there. The other one, very important, is W3C Verifiable Credentials. And verifiable credentials, to be honest, you can really see it as a different way of doing certificates. The only thing in this case is that we don't have a PKI or a central authority giving out this certificate. It's basically a JSON document that is signed by that key that I put on the distributed infrastructure. There are 3 roles with verifiable credentials. You have the issuer, the verifier, and the holder. In this case, if I look from my perspective, I'm a Microsoft employee, so Microsoft could be an issuer. And issuing me as an employee, the holder, a verifiable credential that will say that I'm an employee of Microsoft. Now, what I can do with that document is that I can go to the Apple Store. Because actually, as a Microsoft employee, you get a 10% discount in the Apple Store, which is more than in the Microsoft Store, which is very interesting. So I can go to the Apple Store and say, hey, I want to buy that new iPad, iPhone, whatever beautiful new thing they brought out. And I want a discount because I'm a Microsoft employee. And I can prove it to you. I have this verifiable credential, which you can verify in that, and now it's called Verifiable Data Registry. That's that distributed infrastructure. So I can hand it out to Apple. They can verify that this document is being signed by Microsoft by looking on that registry and say, oh yeah, you are a Microsoft employee. You get a discount. Now, in this case, it's only for a discount. But another scenario where you can think of is that, in this case, the issuer could be the government, could be someone who providing me with a driver's license, which is a digital version. Me as a holder, I have this driver's license in my wallet, and I can use that in specific situations. One of a very important situation where you want to use your driver's license when you're a little younger is to buy wine. So when I go to the supermarket and buy wine, actually the last time was, I'm very proud of it, 6 months ago, that someone asked for my ID. But still, when I go there and I show my driver's license, the person behind the counter that's selling me the wine, they only need to know that I'm 18 years or older in the Netherlands. They don't need to know my first name, my last name, my date of birth, that I can drive a tractor, which is really true since I renewed my license. You don't want me on a tractor, but still, I can do it. So that information is not important to that person. That person only needs to know you're over 18. And that's the thing that you can do with verifiable credentials. As the holder, I'm in control of what data I want to share. So I'm not going to give you my full driver's license. I'm just going to create a presentation out of it, which means that I grab my date of birth, I grab today's date and say, yes, I'm 18 plus today. And the only information I share with the verifier is that I'm 18 plus. Just true, that's what I share. But it's still, because it's coming from the verifiable credential, that information can be verified on that distributed infrastructure and can be seen that this information comes from a trusted party. In this case, it could be the Dutch government that is coming from. So that means that you're also fully in control as a person of the data and what type of data you share, which is also verifiable. Now, let's put together those methods and just do a quick check to see how this works. So I have that scheme, DID, I have a DID method, and I have the identifier. So as part of my credential, I have this identifier, which means that if I hand out my credential as a verifier, I can look up and see get the public key of where this document has been signed with. So I locate the DID document on that distributed infrastructure. I read the DID document. The only thing I care for at this point is that public key, and I verify that verifiable credential. That's it. Those 3 methods together is how that works together. And there's the distributed infrastructure. I forgot that I put in that beautiful animation of this thing popping up. Then, now it's time for a check to see how many of you paid attention to one of the slides with the DID methods. Because which DID methods do you know or paid attention? Anyone want to name one? YOLO, yeah. It's one. More? Yeah, also one, yeah. So I want to pick 2 example DID methods. Totally random. It's not that we've implemented them in one of our products and that are the only 2 methods that are part of our product. Totally random. Just close my eyes and pick one from the list. So, example DID methods. I want to do two fully different methods. So the first I want to start with, which I already mentioned, is did web. And this I just stole from the RFC, a new did method that allows participants. It's not that new anymore. I think it's already 2 years old now, but yeah, marketing. To bootstrap trust, hey, trust, using a web domain's existing reputation. Beautiful. I think I couldn't say it any better. It basically means that the trust is gained because I can prove that I'm the owner of this specific domain. That's it. Now, I can already see all your security minds going like, ooh, I see all kinds of security weaknesses there, which are actually there, yes. Because how it works is that this is how such an identifier looks. It's did web example.com. In the standard, we specified that the identifier, every domain has a well-known endpoint. So based on the identifier, which in this case is example.com, I know how to get that did document. So I can go to the .well-known/did.json, and there is an example of a did.json document. Now, you can, I already told you, it's all very hard to trust me, so I just want to show you. Then I need to open it up on the right screen. I know I can switch screens, but I don't feel like doing it. So this is my colleague who's called Rohit. It's here. It's public information, so everyone can look this up, because that's the idea with the decentralized identifiers, that it's a trust method for everyone to get that trust. So basically it means that even if I don't know you, I can verify information because this is a public document that is out there. That's also why you don't want to put any personal identifiable information on there or in there. Like in the past, I know when, again, blockchain was a cool thing and it sounded like blockchain is awesome for identities. We're just going to put everyone's identity information on the blockchain. So it's going to be there forever and ever and ever. You're laughing, but it's actually happened. There were companies doing that, directly on the blockchain, putting personal identifiable information. Now, this looks not as nice, so I installed a plugin. I just want to demo it. This is way more readable. But you can see a few things here, right? You see the identifier where the domain is on the top. And let me zoom in a bit. So the identifier on the top. And then you see some information. You see a link domain, which basically is there to verify that this domain is there. There's actually another document verifying the ownership of this domain, which is also there. And then you see something, a concept which is called an identity hub. Now, an identity hub is kind of an extension on these type of things, which basically is a database that can contain information that you don't want to put there out publicly. So what I can do with an identity hub, this is a standardized API, is that when someone presents me with a verifiable credential, which are telling me that they are an employee of a specific company, I can go to that hub and request for some more information, and then that company can allow or deny that information coming through that API endpoint. So it's basically an extra database where I can store information I don't want to put in a verifiable credential, but I do want to make it available, but I want to have a process behind it to do so. Then you see the verification methods, which is basically just the public key of this domain being there. So that is did web. And it's pretty easy to start with this one. It's just, you need that JSON document, you put it on the web server, on that location, and you're done. Now, a little bit more of an advanced way of doing it is something called did-ion. And did-ion stands for Identity Overlay Network. And this has been created because when we started to look at decentralized identities, blockchain was a big thing. It still maybe is, but blockchain has a few disadvantages. One of them is it's very costly to put stuff on it. There's a lot of energy consumption next to it. And as Microsoft, we wanted to be carbon neutral by 2030, and we want to pay back all our carbon in 2040. So when we told someone, or actually we didn't tell them, someone figured out we did something with blockchain, there was a lot of commotion. So there needs to be something there. That's one issue. The other issue is maybe even worse, is that it's not very fast to look something up. And if I want to sign into a website or I want to present information and I want to get some data back, I don't want to wait for how many minutes to get that information. So the identity overlay network is basically a distributed network as a caching layer on top of Bitcoin. And there's a reason Bitcoin is there. So this is a standard built or a method built by the Decentralized Identity Foundation. And to be honest, if you open up the specification of DIT-ION and look through the document, you see the name of my colleague popping up a lot of times. So we actively contributed to this one as well. And the reason we chose Bitcoin as the network underneath it is that Bitcoin has been proven as one of the largest networks. And also, they're not big security incident known. And for a method that goes about trust and verification, you want something like that. Now, of course, what happened is that when we walked into corporate offices and tell them, we have the solution for your identity problems. And by the way, it's built on Bitcoin. If you don't understand the background or have any technical information and you will mention Bitcoin to someone, probably all red flags will go out there. So that's one thing we learned when starting with this, is that having other methods is a very important thing to, even though this is the most secure one compared to DIT Web, it's finding that balance between what you want to do and what feels good for your company. And that's why there's a choice of multiple methods there. Now, the identity overlay network, what I said, it's like a layer 2 on top of Bitcoin, so it does the caching. So every 10,000 transactions, only the transactions together will be anchored on Bitcoin. So there's no personal identifiable information. It's just a set of transactions that we anchor on the Bitcoin, which build that trust layer. For the ION network, everyone can also run a host. So you can, if you have a Raspberry Pi lying around somewhere, you can start it up and you can be part of the identity overlay network. How it looks, let me just... So there's a Explorer, this is the one, but you can also have your own lookup on the network. We have a, there you go, DIT and then ION and then the identifier. So on the ION network, we can have a lookup of this information. And what you will see here is that you basically get back the same document, right? This is that decentralized identifier standards. There's a little bit more information in here, like the identifier is pretty long, but you have the linked domains here as well, and you have the verification methods. It's just a different way of storing the same JSON document and getting that information out of there. So that's the decentralized identifier, which is on the ION network. And then the verifiable credential is signed with the public key, which is part of the decentralized identifier document, which lies on top of that. So what I just showed you, did ION spot the typo in the numbering? Look up on the ION network, and there you have it. That's the document that is there. So this is how that method works, and this is basically for every method you can apply the same. It's just a different way of reading and writing data, putting data on a trusted infrastructure. Okay, so then I want to jump into how you can use it. I want to show you a little demo on the scenarios that we built, and also give you some guidance on how you can maybe look at this yourself with Microsoft technology. So Microsoft Entra Verified ID is basically the implementation of these standards that I just talked about. So basically what we did, like you saw all those things of looking up and writing things on a distributed network and generating a verifiable credential and all that stuff. We just put that into a box and provide an API. And that API, you can say, issue a credential to someone and verify this credential. And we will take care of looking up on the right network and providing that trust there. If you think back about the verifiable credential, you have the issuer and the verifier and the owner. And the owner needs a wallet to store those verifiable credentials securely. So our implementation of the wallet is built into the Microsoft Authenticator app. Fun fact, for the people who has the Authenticator app on their phone, it's just in the production version. Maybe you've never spotted the Verified ID tab in the right top bottom, but I will show it to you in a bit. But it's in every Microsoft Authenticator app currently. Now, this sounds cool that it is in Microsoft Authenticator, and a lot of people have that. But we also know that there are a lot of scenarios where I, as in a business-to-consumer type of scenario, I don't want to tell to my consumers, you need to download the Microsoft Authenticator app to get this credential there. So that's why we provide an SDK for Android and iOS, that you can use the same technology out of the Microsoft Authenticator app into your own app. And we open source that SDK. So that's available on GitHub, where you can build your own wallet. Of course, because this is all built on those open standards, you're free to use anything else that support that open standard. We just give you a verifiable credential. So a colleague of mine, just from scratch, just for fun, built a wallet in a browser, which is there for 10 minutes in memory just for demo purposes. But because it's using that standard, I can just save that in that wallet. So it's not that you need to use the Authenticator app, but if you want to try it out at first, it's the easiest way of doing that. Now, as I said, the two methods I explained were totally random and not related to the product, but by coincidence, they're all both supported on Entra Verified ID. So DidWeb, which is now our default, and DidIron, which is the second one. DidWeb is the default because it's a little bit easier to set up, because it doesn't require like anchoring stuff, which we do for you, but it requires a little bit more effort to do so. So that's why we chose DidWeb as the standard, but you can, during the wizard, you can pick and choose whatever you want to pick there. Okay, at this point, I'm just gonna switch my screen. Let's see if it works. There you go. And then I want to show you a little demo about how that should look. If my browser, there you go. There we go. So this is a scenario where we're doing onboarding. So it's my first day, and what we've seen also with the past few years, that there's a lot of remote onboarding. But how do you check if really someone is who he says that he is joining your company? I literally had a customer conversation a few months ago with a consultancy firm that were like, we want to have something that will verify someone every time they access the system. Because they had someone onboarding and then someone else using that same account. So basically they had one person signing up, having the right credentials, and then multiple other people would do the same. If you maybe remember, Uber had kind of the same problem a few years ago as well, where one driver signed up and they just rented out their Uber driver account to others. So in this case, it's my first day of work, so I'm gonna sign up. And the first thing I need to do is verify my identity. Now, in this case, we're going through a third-party identity verification company. And with Entra Verified ID, and I don't want to make it a full sales pitch, but just give you some information here, is that we have partnerships with a few of the biggest identity verification partners that directly integrate. But because these are just APIs, you can integrate it into any system you have. And if you have your own verification system, it just works with that. Because what I'm going to tell you what's happening in the background when I'm going to do this. So first of all, when I press verify, I need to give some information about myself. So I need to upload the government ID, and then I need to take a selfie. And that information is verified by this partner. But what I said, if you have your own system, you can use that. Because the only thing that we're going to do here right now is verifying this information. And then I always forget to share my phone screen. Just give me a sec for the mirroring, then you can also see that. Because the verification is complete. Now the screen mirroring needs to work. Still loading. Anyone knows that is there an option in screen mirroring to just keep the screen mirroring going, so you don't need to reconnect every time you start your demo? It's there you go, almost there. Only need to enter a PIN, and then I can share my screen with you, and you can see what's happening when I'm gonna continue. There we go. And I know you're not seeing it yet, but that will be just a sec. There you go. So here you see the Microsoft Authenticator app. And what I said, there's a little tab called Verified IDs in the right bottom. And I don't have any Verified ID in here right now. So I'm just going to say OK on this one. And what's going to happen is that right now we're doing an API call to our backend saying generate a new verifiable credential. And as a callback, I will get a QR code, which I can scan. And there's a pin next to it. Now, this is just a random generated pin, but this could be something that you could provide from any resource while saying generate this credential. So I'm just going to enter the pin. And you will see I get a credential, which I can add to my wallet. And after I added it to my wallet, you can see what type of information is in there. So I'm older than 21, fully verified. I live in your city in New York, beautiful place. You should visit, especially during spring. It's the leaves, everything. It's beautiful. I can also see some activity. So it has been issued by True Identity in this case. So if we're going to return to the onboarding process, I can say access the personalized portal at this point, which initiates another API call. And what it now says, instead of generate a verifiable credential, it will ask to verify a credential. There we go. So what I'm going to do right now is the same thing here. That doesn't work. I need to do that on my phone. Is that I'm going to press this button, scan that QR code, and now it's going to ask me for that verifiable credential, and it's going to ask me what type of information do I want to share. So I can see what am I sharing, what information, and then I can say, oh, I want to share this information with this Woodgrove employee, which is a verified domain. Now, I told a little bit about the selective disclosure of information. That is something that is coming soon because the reason we haven't implemented it yet is that the standard for the selective disclosure has been revised, and there's a new version that just came out last month. So we're building it in. We didn't want to build in a version that we then needed to replace with something else. So when I press share, what will happen is that the Authenticator app will send that information to our backend, and then the website can get back that information with a callback and also get the information from the verifiable credential. So if I press continue onboarding, you will see the information that was in there is also here displaying in the portal. And the other interesting thing about this technology is that this information is in this card, which is only in my wallet. Theoretically, as a company, I don't need to store this information. I can just get it every time someone will just scan the QR code and sign in. So there's no central database needed. And then think about things that you need to implement around storing data, GDPR type of stuff. This could really ease that stuff up, leaving the data with the user and not needing to store it yourself. Also, when I go back to my phone and I look into the card, I can look into activity and I can see that I presented it to Woodgrove employee on which date and which card that I presented. Now, the next thing I want to do is I want to show people that I'm an employee of Woodgrove, so I'm going to get an extra card. So same process. I'm going to scan that QR code, which is there. And if you were quick enough and had the Authenticator app open and now enter the PIN faster than I do, then you're an employee of Woodgrove. But good news, this is a public demo. I will share the link to it as well, so you can try it out. Only thing you need is a browser and the Authenticator app or any other verifiable credential wallet. Now I'm a verified employee, and what I can do right now is order some new equipment. Now, you probably heard of some budget cuts within Microsoft. Woodgrove has the same. You need to pay for your own device. It's crazy, but you get an amazing discount. So I can go to Access Discount, and instead of signing in, I'm just going to say verify my employee credential. Same thing happens here. I'm just going to scan the QR code. It's going to ask me now for a different card. It's going to ask me for a verified employee, so I'm going to share that. And this is basically the scenario where I talked about being a Microsoft employee in the Apple Store. Look, look, look. Wow. Awesome discounts. And look at those new devices. A Surface Laptop 3. Wow. So happy. Just a scenario here about how the onboarding works. This is like one of the scenarios. And I think you can probably also think yourself of the multiple scenarios that this can bring. So this was the onboarding experience. Employee visit the portal, validated by a network partner, and so on. And in the end, you will be able to sign in. But it does mean that in the normal case, and we've implemented this at customers, is it was a weeks, months process in getting the right documents in, getting that the verification. And now it's just a QR code that I need to scan, I need to identify myself, and I can onboard. Now, the fun thing is that you can also implement this stuff with other current technologies for onboarding. So if I press the play button, there you go. So I'm going to the onboarding portal, and this is my first day of work. I got my laptop, so I'm going through the same process. I'm taking a selfie, and I'm uploading a government ID. I will press next. We will verify this information. Blah, yeah, you already seen that, but it's always nice to see it another time, right? Verification complete. And now it's going to add my credential to the Microsoft Authenticator app. So this is the experience when you're on your phone. We're just calling the app and put it in there. Because it's pretty difficult on one phone to scan a QR code with the same phone. That is actually something we learned during the preview of this product. We will get a callback that it's been added, and I can go to step 2. So I'm going to present my verifiable credential. So open the authenticator. I talk way faster than this person clicks. Then I'm going to share this information with my employee, proving that it's me. And what will happen then is if I go back to the onboarding portal, I get a temporary access pass. So basically, this is a temporary credential I can use to set up my machine and register for a passwordless method. This is a code that is only valid for 20 minutes, 10 minutes, 5 minutes, whatever you want to put in there. And it's also a code that can only be used to sign in and register a method. So I enter that temporary access pass on my machine that I got after verifying myself. And then when I sign in, I can set up for a passwordless method. In this case, I can do Windows Hello for Business. And after that, I'm signed in, ready to work. I don't have any passwords. And I'm just using passwordless authentication using Windows Hello for Business. So this is how these technologies could merge into each other. And for example, we also see other use cases. Think about B2B scenarios, where I have a partner that I want to invite to a project. But before I can get someone on the project, I need to have them verified, I need to have our account set up, all those type of things. And we see definitely an opportunity here for a short-term project. Let's say you have a project of a month, for just someone coming from another company, identifying themselves, being an employee based on a verifiable credential, and at that point, just get access to the things they need for that month, and then they're done. Which saves a lot of process, creating accounts, setting rights, all those type of things. Other scenarios where you could think of is self-service password reset, for example. Instead of getting an email, phone call, text message, paying for Twitter Blue, you can just show your verifiable credential and reset your password. So what I said, a few common scenarios here, fast remote user onboarding. These are the only slides I stole from the marketing deck, but I just wanted to share some of the scenarios here. Account recovery and the custom business solutions. What I said, this is just we providing those APIs, and I didn't want to show the admin portal because I only have 2 minutes left, but if you want a demo, I'm here all day. Which will generate the API call for you. So it will just tell you this is the endpoint, this is the JSON you need to drop, and then you can verify this credential. One other thing that we've built in is a network of people who are part of this, because the whole thing only works if there are verifiers or actually if there are issuers. If no one is issuing a credential, nobody can verify. So this is a really important thing here that that there need to be more issuers. Now there's, and unfortunately I cannot say it right now, but we have a Microsoft Secure event coming up in 2 weeks. We're going to do a big announcement of an integration with one of our other big brands. with Verified ID where we have trouble people pretending to be someone else. And you can fill in the blanks, but it will be public in a few weeks. And I think that will definitely start off a great way of getting more people issuing credentials and getting more of those use cases there. Now, how to start? What we do is actually we can do a POC on this in a day. We have examples that we can change a bit. We just need to know the scenario. We will build a storyboard, which will show you in a bit how an example looks. Build a prototype, do a proof of concept, and then hopefully go into a pilot phase and go from there. Now, we already collected a lot of storyboards. I just wanted to show this one for existing users, MFA onboarding. This is the thing that we do with our customers. Talk through what is your scenario, then create a storyboard, and based on that storyboard, we will build a proof of concept. Here are all links that you can find a lot of information. The first one is really marketing stuff, just skip it. Own Your Identity, Did for Devs is our developer documentation. Get started for free. Fun fact, this is a free product. The only thing you need to pay for is a few cents to store the key that you use in a key vault. So you need an Azure subscription, but if you don't have a subscription that you cannot use, we can provide you one. Before I'm going to say where, the demo I just showed is the one on the bottom, and I just got an email just now that we're going to launch a new government-focused demo pretty soon as well, with a few government scenarios. And what I said, the did demo, and if you want to build it yourself, I created a lab guide that I did at an event a few months ago, and you can find it at aka.ms/ilovecats, because I love cats. And it was free. So I'm 1 minute over, sorry about that. Questions? Not sure if I need to get out of this room, but I see some questions, so maybe take like 2, and then otherwise you can come afterwards. Yeah.
I saw that you're using QR codes. Would it be used for NFC devices also when you want to authenticate with NFC devices?
So the question is if you can use it with NFC devices. We actually, it's not public, but we build a proof of concept using NFC to do those, share those credentials, or basically initiate the process. So it can work. We don't have anything out of the box, but you can build it yourself doing that. So that's definitely one of the scenarios. Yes. I saw one question there.
Can you use IDIN as trusted identity provider?
Can I use? Sorry. IDIN.
Yeah, IDIN.
Basically, so there is a bridging protocol for OpenID Connect. I don't know the details of IDIN. It's been a very long time since I looked into Dutch stuff. But if they support OpenID Connect, you can bridge OpenID Connect into a verifiable credential. So we actually have a solution called Azure AD B2C, which has a kind of a flexible framework around it. We built integration with this into B2C, which basically first asks you to authenticate using OpenID Connect, and then grab that information and put it and generate a VC out of that, and then you can use that VC to sign into specific things. So yeah, definitely. Okay, just social stuff. I'm not sure who's still on Mastodon. I tried it. I'm never there, so follow me on Twitter. And with that, if you have any questions, please come see me afterwards. What I said, I will be here until the end of the day, so more than happy to talk to you, and thanks for your attention. Have a great event.